Hi guys, welcome back. Fred here from AF Math and Engineering. This is a video on effective interest, and I know this topic, especially in engineering economics, gives a lot of people trouble because when I took it, the people that I studied with had problems with it. With that being said, we're going to go over the concept, and then we're going to do an example question. Hopefully it makes more sense to you. Let's read the question. Suppose you have $500, suppose you make $500 monthly deposits to a registered retirement savings plan, an RSP, that pays an interest rate of 10% compounded quarterly. Compute the balance at the end of 10 years. Okay, so there's a few things we need to, information that we need to extract from this question in order to start to solve it. Okay, so what I've done is I've written down the formula here for effective interest rate. So this I, and we'll just do I sub effective, okay, so you know which one that one is equal to 1 plus R, which is the interest rate, over M. M in this case is the number of compounding periods per year, to the power of C, where C is equal to the number of compounding periods, divided by K, which is the number of payment periods. And these are always per year, okay? And K is the number of payment periods per year. Okay, so if there's if it says compounded quarterly, that's 4. If it's compounded monthly, that's 12. Payment period, same thing. If there's 12 payment periods, monthly payment periods, that's 12. Daily payment periods, that would be 365. So that kind of thing. That's how you use that formula. And let's take a look at the question and see what information we can get out of it. Okay, so first we're asked to compute the balance at the end of 10 years. Okay, that means that we're going to be computing a future value. And if we look at the first part of the question, suppose you make $500 monthly deposits. Okay, that's an annuity. So every month you're depositing $500. So we have our A value. So we're going to be using F given A, the formula for F given A, because we want to find a future value given an annuity. So our A value here is $500. That's good. And what else do we have? So we have an RSP that pays an interest rate of 10% compounded quarterly. So we know our interest rate, which is 10%. Okay, that's not the effective interest rate yet. We're going to have to convert it into the effective interest rate. And you always do effective interest rates, or you need to calculate the effective interest rate when your compounding period is not equal to your payment period. Okay, so what that means, if your payments or your deposits don't match your compounding, like in the earlier parts of the other questions that we did, compounding was the same as payments. Okay. But like it was all yearly. But in this one, we have quarterly compounding and we have monthly payments. So we need to derive an interest rate that we can apply, and we can use the formulas that we have on the formula sheet in order to solve this. So with that being said, let's continue. So we have our R equals 10%. Our payment periods. So what are our payment periods? So we're depositing monthly. Okay. So if we go back here, we have payment periods per year. That's K. Our K value is 12. And our M is our compounding periods per year. Well, it says it here, it's compounding quarterly, so there's 4 quarters in a year. So M, in our case, compounding periods per year is 4. And now we can start to go ahead and solve this problem, okay? So let's start to plug into this formula here, I effective, okay? And I've just written a little description under here. It's the effective interest rate per payment period for discrete compounding. We'll do another video on continuous compounding, which is really easy. This is also pretty easy, but just remember this formula and you're good. So let's start with the formula. So we have 1 plus R, so our interest rate, our original interest rate is 0.1, over M, the number of compounding periods per year. So that's, in our case, is going to be 4, which is quarterly. To the power of C, C is compounding periods per year, which is 4, over payment periods per year, which is 12, minus 1. Okay. So if we go ahead and calculate that out, okay, the inside of the brackets is going to be 1 plus 0.1 divided by 4, okay, that is 1.025. 4 divided by 12 is going to be the power of 1 over 3, or the cube root, minus 1. Okay, so that is going to be all right, and we have an effective interest rate. We multiply that by 100 of 0.826%. Okay, so what is this? What is this value, right? Because this can be confusing. What is 0.826 mean? So 0.826 mean is that we took our original interest rate here of 10% and we converted it to the time frame of where the deposits are made, okay? So since we have monthly deposits, this is now a monthly interest rate as long as we're earning 10% compounded quarterly, okay? So what we did is we converted the interest rate to the deposits. And now that we did that, we can go ahead and we can start to solve what the question's asking for, which is to compute the balance at the end of 10 years. Now what we need to do is we need to apply, as I said, our F given A formula. Okay, so we need to find F given A. And what this looks like, okay, is we're going to have, let's say this is year 0. Okay, we're going to have a bunch of payments of 500. Okay, these are all 500. These are months, 2, 3, 4, 5, 6, 7. These are months all the way up to 120. And at 120, we're also going to have a future value of all of these where our interest rate is 0.826% per month. Okay, so what we need to do here is we need to apply our F given A formula, okay? And so this is what it's going to look like. So we want to find F, and we're given A, okay? A is 500, and we're going to apply the factor for F given A, 0.826, 120, okay? Because 10 years and there's monthly deposits, right? So 10 times 12 is 120. However, we don't have an interest table for 0.826. You might be thinking that, how do we solve this? Well, this is a case, okay, where we're going to need to use the formula. Okay, so if you ever get an interest rate that doesn't have a interest table for it, so you can't just go to the table, you're going to need to go ahead and apply the formula that is on the formula sheet. Okay, so if you take a look, it's on the screen now. We're going to take a look at compound amount F given A formula, and I'm going to write that down on the page for you here. Okay, so we have A times 1 plus I to the n minus 1 divided by I, and we have all these values here, so let's go ahead and fill them out. And remember, don't use 0.826, okay? We were going to have to divide that by 100. It's to the power of 120 minus 1 over 0.00826, okay? And all we need to do is go ahead and plug this into our calculator. Come down here. Okay, and that means that our F value is $101,907.89. Okay. Okay, so what is this? What is this value? Well, this is the value in 10 years. So after 120 months, and I'll write it up there for you too. Okay, so at the end of these 120 payments of $500 every month, where we were getting 10% interest compounded quarterly, and our deposits were monthly, as I said, at the end of 10 years, we're going to have $101,907.89 in our account. All right, so I hope you learned something there. I hope I explained that at least half decently. Thank you for watching, and like and subscribe.